Hello and welcome to today's section in further mathematics. Today we'll be talking about mutually exclusive event. But before we proceed, I'd like us to take a quick review of our previous lesson. Okay, welcome back. Now, when you talk about mutually exclusive event, now let's split the word. Mutually means together. Exclusive means being apart. Now, this is to say we are talking about two different events that are together but can only appear separately. They are together but they can only occur separately. That is to say, mutually exclusive events are two events that cannot occur at the same time. Example, you can't be alive and at the same time being dead. It's not possible. It's either you are alive or you are dead. The two events cannot occur at the same time. Now, you can never be short and at the same time tall. It's not possible. And at the same time, you can never be dark and chocolate in complexion. It's not possible. So it is either you take one at a given point in time and you leave the other one. All these are mutually exclusive events. You can assume the position of being alive and you can assume the position of being dead. That is to say, these two work together, but they are separately in existence. You cannot be the two at the same time. So that is what a mutually exclusive event is. For example, now, like if I give you a die, the one used in trained Ludo, I say cast the die. 5 cannot show up in a die and at the same time 3 showing up. It's not possible. So it is either if 3 shows up or 5 shows up or 2 shows up or 3 shows up. You cannot say I got 3 and 2 in a single toss of a single die. Now let's do one example of a mutually exclusive event. You say example 1. In a single throw of a fair die, what is the probability of an even number or a perfect square showing up? Now, in probability, the word or simply means plus, and the word and simply means multiplication. And let's bring out our sample space. A single toss of a die. Now, if you cast a die, it is possible that 1 shows up, 2 shows up, 3 shows up, 4 shows up, 5 shows up, or 6 shows up. So our total, these are sample space. These are sample space 1 to 6. Now the probability of having 1 is 1 over 6. Probability of having 2 is 1 over 6. Probability of having 3 is 1 over 6. Each is 1 over 6. Now let's move forward. Now what's the probability of having even numbers? Now what are the even numbers? Even numbers are 2, 4, and 6. So probability of even numbers is equal to 3 over 6 because their total are 6 and even numbers are 3, so which is equal to 1 over 2. This is the probability of even number. Now, or a perfect square. Now, this is probability of even. Now, probability of a perfect square. Our perfect square here is equal to 1 and 4. We just have two perfect square, 1 and 4. So the probability of a perfect square is 2 over 6, which is 1 over 3. So the probability of having even or perfect square is equal to 1 over 2 plus 1 over 3. Our LCM is 6. 6 divided to is 3. 3 times 1 is 3 plus 2. 2 times 1, 2 is equal to 5 over 6. So the probability of having either even number or a perfect square is 5 over 6. Now, and this is for the mutually exclusive event. Now, let's talk about the independent. Independent and dependent event. So with this, when you talk about dependent, that is to say A relies on B to occur. That is, the occurrence of one is being influenced by the occurrence of the other. Now let's solve the example that is right in front of us. A class contains 8 male and 7 female. If 2 students are picked at random, find the probability. These are example 2. Find the probability that there are A, both ladies, B, both male, C, of the same sex, and D, of different sex. Now we want to solve this from here. Now, A, probability of both ladies, now is equal to we have a probability of female is 7 over 15, because the total number of people in the class are 15. 8 plus 7, which is equal to 15. So the probability of picking a female is 8 over 7. And the probability of picking the second female, you know, after taking one female out, you have 6 female left. Now the total will now be 14, no longer 15. So now the probability of taking the second lady will now be 6 over 14. Now 7 times 6 is equal to 42 over 15 times 14 is equal to 210. 42 into 210 is 1 over 5. So the probability of picking both ladies is equal to 1 over 5. Now the B part of it, this is the A part of it. Now the B part of it, the probability of picking both male is equal to, okay, how many male do we have? from the question here, look at it, is 8. So probability of picking a man is 8/15. That's probability of picking the first male. Now after picking that, we now have 7 males left. That's probability of picking the second male out of 14. So which is 8 times 7 is 56/15 times 14 is 210. Now a figure here is 214 over this, which is 4/15. Now the probability of picking both male is 4/15, while probability of picking both female is 1/5. Now the C part of the question, what's the probability of picking the same sex? Now talking about picking the same sex, that is, it's either both male or both female. Now since we have probability of both male and probability of both being female, so it's either, since we are talking about both sex, so it's either they are both males or both females. So or I said the symbol for or in probability is addition, so it's 1/5 plus 4/15. The LCM here is 15. 15 divided by 5 is 3. 3 times 1 is 3 plus 15 here is 15 is 1. 1 times 4 is 4. So the probability is 7/15. The probability of both from the same sex is 7/15. Then probability of both being from different sex is 1 minus probability of same sex. So it's 1 minus 7/15. We still look for the LCM here, being 15. So it's 15 minus 7, because 15 divided by 1 is 15 times 1 is 15. Minus 15 divided here is 1 times is 7, so which is equal to 8/15. So I would like to say a very big thank you for being part of today's lesson. Do yourself a favor by attempting the question that will be popping up very soon on your screen. We'll be very happy to get response, questions and feedback in our comment section. We'll see you in our next lesson. Thank you.